Now we're on page 4 of section 6.5, and we're going to look at the identities for the cosine and inverse cosine. So similar to what we saw for inverse sine, we got inverse cosine of the cosine of x is equal to x if x is between 0 and pi. And the cosine of inverse cosine of x is equal to x if x is a number between -1 and +1. Okay, so we're going to take a look at an example. We're going to find the inverse cosine of the cosine of 4 pi over 3. Unfortunately, 4 pi over 3 is not between 0 and pi. So we can't use the identity up above. We need to first find the cosine of 4 pi over 3. So we're going to have this is equal to the inverse cosine. And the cosine of 4 pi over 3 is equal to -1/2. So we need to figure out the inverse cosine of -1/2. So I'm going to say this is equal to y, where the cosine of y is equal to -1/2, and y is between 0 and pi. So now I need to think, what is an angle between 0 and pi whose cosine is equal to -1/2? And since the cosine of 2 pi over 3 is equal to -1/2, and 2 pi over 3 is between 0 and pi, we end up with the answer being 2 pi over 3. Okay, next up we're going to look at the inverse tangent function. So again, we have a problem that if we use the whole entire function, the inverse won't be a function. So we need every y to have just one x. So that means that we're going to restrict the domain so that f inverse is a function. And the way that's been done is by restricting the domain to be between -pi/2 and +pi/2. So we're looking at just one single part of the tangent function, and then the blue graph is the graph of the inverse tangent function. So just like we've done with sine and cosine, we get our definition, y is equal to inverse tangent of x, or arctangent x. That means x is equal to the tangent of y, where y is between -1/2, -pi/2, excuse me, and +pi/2. So that's very similar to what we got with our sine function. Next, we're going to find the inverse tangent of 1. So I'm going to say this is equal to y, where the tangent of y is equal to 1, and y is between -pi/2 and pi/2. Right? And the angle that's going to work for that is going to be the angle pi/4. So since the tangent of pi/4 is equal to 1, and pi/4 is between -pi/2 and pi/2, inverse tangent of 1 is equal to pi over 4. Okay. And now we're putting together a couple trig functions. Previously, we've done things like the sine of the inverse sine or the cosine of the inverse cosine. Now we're going to mix together inverse tangent with sine. So we're not going to use any of the identity functions on this one, but we're just going to figure out the tangent of 0 first. Okay. So I'm going to say this is equal to the sine of y, where inverse tangent of 0 is equal to y. And so that means the tangent of y is equal to 0. And 0 is between negative pi over 2 and pi over 2. Okay, and the angle that's going to work there is just 0. So since the tangent of 0 is equal to 0, oops, up above, this 0 should have actually been a y here. And 0 is between negative pi over 2 and pi over 2. That tells me that the inverse tangent of 0 is equal to 0. So over here, I need to find the sine of 0. And I know that's equal to 0. Okay, so now we're done, I guess, with page number 4. I'm going to stop the recording.